Imagine a world where you can control a computer, a prosthetic limb, or even a drone, using just your thoughts. This is not a scene from science fiction, it is the reality of today's emerging neural interface technology. Neural interfaces are bridging the gap between the human brain and machines, opening doors to incredible innovations in medicine, communication, and artificial intelligence. Welcome to the third episode of Tech Uncovered, Discover, Learn, Apply, the series where we break down revolutionary technologies shaping our future. If you have not yet watched our previous episodes on radar technology and LiDAR technology, be sure to check them out after this video. And do not forget to subscribe to the channel for more exciting insights into the world of technology. Neural interfaces, also known as brain-computer interfaces or BCIs, allow direct communication between the brain and external devices. These systems work by detecting electrical activity from neurons and translating these signals into digital commands that machines can understand and respond to. There are three primary types of neural interfaces. Invasive BCIs involve the implantation of electrodes directly into the brain, providing high-precision control but requiring surgery. Non-invasive BCIs use external devices, such as EEG headsets, to read brain activity from the surface of the scalp. These are less precise but safer and more accessible. Partially invasive BCIs are implanted under the skull but do not penetrate brain tissue, offering a balance between precision and safety. These different types of neural interfaces each play a crucial role in unlocking the potential of direct brain-to-machine communication. The human brain functions through a network of neurons that communicate using electrical impulses. Neural interfaces capture these brain signals using electrodes or specialized sensors, process the data using advanced algorithms, and convert the information into digital commands. Artificial intelligence and machine learning play a critical role in refining this process. These technologies help neural interfaces become more accurate and responsive, allowing users to control devices with increasing precision and efficiency. Neural interfaces are revolutionizing multiple industries, creating possibilities that were once thought to be impossible. In the field of medicine, BCIs are enabling individuals with paralysis to control robotic limbs with their thoughts. Speech neuroprosthetics are helping people with conditions like ALS regain their ability to communicate by translating brain signals into words. Deep brain stimulation, or DBS, is being used to treat Parkinson's disease, epilepsy, and even depression. Beyond medicine, neural interfaces are enhancing human cognition and intelligence. Research is being conducted on memory-boosting implants and brain-to-brain communication, which could one day allow humans to share thoughts directly. The gaming and virtual reality industries are also adopting neural interfaces. Mind-controlled gaming is making its way into the market, promising a future where players can interact with virtual worlds using only their thoughts. In the defense sector, military researchers are exploring the use of neural interfaces for drone operation and secure communication. These technologies could enable soldiers to control systems hands-free and transmit information more efficiently. The potential applications of neural interfaces are vast, and the field is only beginning to unfold. Despite their immense potential, neural interfaces come with significant challenges and ethical concerns. One of the primary obstacles is the technology's current limitations. Signal accuracy, real-time processing, and power requirements all pose significant hurdles to the widespread adoption of BCIs. Scientists are working to refine the technology, but these improvements take time. Another major concern is privacy. Neural interfaces collect and process brain activity data, raising important questions about who owns and protects this information. If neural data were to be hacked or misused, the consequences could be severe. There are also ethical concerns surrounding cognitive enhancement. If brain augmentation becomes widely available, will it create a divide between those who can afford enhancements and those who cannot? How much control should humans give to machines when it comes to decision-making? These challenges must be addressed as neural interface technology continues to evolve. The future of neural interfaces is incredibly exciting. Researchers are developing wireless BCIs, eliminating the need for physical connections between the brain and external devices. Brain implants designed to restore lost memories are also in development, potentially offering a solution for individuals with Alzheimer's and other memory-related conditions. Some visionaries even predict that humans and artificial intelligence will eventually merge, creating a form of hybrid intelligence. While this concept is still in the realm of speculation, rapid advancements in neural interfaces make such a future seem increasingly possible. Neural interfaces are poised to change the way we interact with technology, medicine, and even each other. The coming decades will determine how far this technology can go and how it will be integrated into our daily lives. Neural interfaces are unlocking possibilities that once seemed like pure science fiction. From medical breakthroughs to AI integration, the future is being shaped by this extraordinary technology. If you enjoyed this episode of Tech Uncovered, discover, learn, apply, do not forget to check out our previous episodes on radar technology and LiDAR technology. More exciting deep dives into revolutionary technologies are on the way, so be sure to subscribe to the channel and stay ahead of the curve. This episode was brought to you by Physical Sciences Consultorium. If you are interested in collaborations, feel free to contact us at sconsultorium@gmail.com. Thank you for watching, and see you in the next episode.